Hello, welcome back. My name is Paul, and in this demonstration I'm going to be covering stack spoofing alongside recently introduced CET compliant stack spoofing. So you might ask yourself, what is CET? And it's short for Intel's Control Flow Enforced Technology, which is developed to mitigate or defeat a lot of ROP gadget based techniques or especially exploitations. And numerous stack spoofing techniques rely on drop gadgets, drop gadgets to perform the spoofing of the stack, which under CET compliant or enabled processes, it would fail. So we recently reworked how we perform stack spoofing alongside adding it or like introducing a lot more evasive capabilities, and CET was one of those features we also have added, or at least CET compliant stack spoofing. Remember, we say compliant and not actual like defeating CET. These are two different things. We actually don't defeat it, we just comply with it. So on the kernel shadow stack, it will still reveal the actual core stack, but still a lot of security vendors aren't this far. As far as I understand, I think Elastic is one of the leading ones that actually starts introducing those, but let's see about that. So with this being said, let me actually go over to payload builder, generate a new payload, and we are going to generate a full payload with all of the capabilities enabled. And as you can see, for remote injection, we have specified thread obfuscate our context, and for memory allocation, we perform via drip loading memory allocation. So with this being said, let me actually generate it. We have now generated a payload. Let me actually go over to my virtual machine and just start up the session. In this scenario, you would do it via like initial access or whatever other payload delivery mechanism or like technique you have. So let me actually just do this. And as you can see, we have a full callback, calling back. And let me now go over back to my VM. So we're going to target MS Edge, which is one of the few processes that have CET enabled. As you can see, let me actually go open it up. On the mitigation policies, you'll be able to see all of the listings, and under here we have stack protection, which is an alternate word for Intel CET. As you can see, the CPU verifies function return address at runtime by employing a hardware enforced shadow stack. This is exactly what CET does. And let me actually go back, and as you can see, I also have enabled to see whenever a process is CET. So with this being said, we know that MS Edge is a process with CET enabled, and we are going to try to inject into it. Let me go over to my process explorer. Actually starts listing silently. I don't need any open handles to any process. I just need to see all of the processing running. And as you can see, we have here MS is running. Let's do right click on it, inject. Profile, I would say, should be enough. Let me actually go to the full one, and we don't need to track it. This flag allows you to kind of track all of the injected payloads you have in memory, and whenever the thread finishes executing, it will finish free the memory that has been allocated in a remote process, which might be very useful in case you do some sort of remote process injection, and after the thread has finished executing, you just want this memory to be freed and removed from the process. But in this case, we don't need it. Let me actually do this, and it's going to utilize the registered injection techniques alongside with the registered memory allocation techniques. This might take a few seconds, considering that the technique is performing a lot of minor tasks, but in the meantime, let me go over to process Still running. Might just give it a second. Perfect. We now have a callback running from MS Edge. And let me actually go over to the process. Let me actually start finding it. Actually, I don't find it. Let me. We have it under thread ID. As you can see, now as you can see, all of the stacks is fully spoofed, even under a CT compliant enabled process. So the entire stack spoofing capability under the Kane agent is fully CT compliant, as you can see. So, and we can still interact with it. Let's do ls C drive, as you can see, and every single API being called from the agent will be proxying through that stack spoofing feature, meaning that if you execute any kind of extension or big object file, all of the calls that's being made is going to be proxying through this stack spoofing extension. So with this being said, it fully demonstrates the capabilities of Havoc Professional and the OPSEC considerations we have. And another thing you can do now in this context is just being able to perform cookie dumping, such as via from King of Knobs cookie monster above. Let me actually do this real quick. As you can see now, we have also modified the object file to perform the downloading via beacon download API. But as you can see now under downloads, you will see we have the edge cookies downloaded as well. And all of these calls being made by the beacon object file will be proxied through the stack spoofing extension as well. So everything is masked and also hidden. So thanks for watching, and I hope you guys enjoyed it. See ya.